and get prepped for the next presentation. Welcome back, welcome back. We'll see if we have a few more people connecting in the next minute or so coming back as well. I'm going to go ahead and invite Matthew onto the stage. I see lots of people joining us now. He's our next presenter, joining us from Canada. So I know it's nice and early for you. How are you doing?
Good. Can you hear me?
Yes, we can. You're in business.
Awesome.
Right. Well, I don't want to eat into your time slot, so let me go ahead and hand over to you.
Thank you so much, Corinne. Hello, everybody. My name is Matthew Young. I work at Kijiji in Toronto, Canada. I've been a front-end developer for 4 or 5 years now, and pretty much spent my entire tenure at Kijiji. And over the course of these 4 or 5 years, we've went through a big shift from React Redux to React TypeScript Apollo GraphQL setup. So learning Apollo GraphQL has been quite a lot of fun, and we've definitely learned a few best practices the hard way, and I felt like I wanted to share some of those things with you guys today. A little bit more about me. I'm a big sports guy. Really like music, from heavy metal to electronic music and techno, and I also like to play video games. Anyway, on to the real stuff. So my title of presentation today is GraphQL, Resolvers, and CodeGen. Let me just get up presentation view here. All right. So first off, what is GraphQL? I'm presuming most people know, but in case some people don't, GraphQL, the graph stands for data structures that resemble the natural way we build mental models and relate concepts. And the QL stands for query language. So according to the Apollo GraphQL website, GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. What's all the hype? GraphQL gives you an easy to read description of the data available in your API. You'll see shortly you can request as much or as little information about a type that you want without a worry of overfetching and over normalization of fields that you don't particularly care about in your use case. And a more intricate schema type could require fetching from multiple data sources, and all those multiple data sources fetches can happen all under the hood on a single GraphQL query request. So you can see a little demo there on the side. We got a category, call to category, which is grabbing some data from category service, some from attributes, all happening in one request. I found this, which I really thought is the truth. The real secret is that GraphQL ensures that the developer and application only loads the relevant and absolute necessary data, even if it's from multiple sources. What is a resolver in GraphQL? Resolver is a function or method that resolves a value for type or field in a schema. Every field by default resolves to its field name from its root parent arguments. So basically, every field of a schema comes with a default resolver, which just looks at the return of the parent resolver and finds its name. So out of the box, for simple data, you really don't have to do anything. If an object is returned, the execution will continue to the next child field until execution completes, until it reaches a scalar type, which is a leaf node. So we'll get into this in a little bit more clarity in a minute, but you can see here we have our top level query resolver, which starts from which is the start of every GraphQL schema. We have our resolver for category, and inside category we're asking for a name, and you can see this is something you wouldn't actually have to write into your code because this is what comes by default. By default, you get root.name. So the resolver comes with 4 different arguments. The first argument being the result of the parent query. So basically, whatever the return is of that category service provider.find is going to be stuck into the name the root argument in the name resolver. The args are arguments passed into this resolver on its own. Context is something that you get initialized from the Apollo server setup, provided to every resolver, and then info holds some other field-specific information. How does the schema and resolvers interact? So just put together a little diagram here to show you. You can see on that initial data tree we saw, we call for category, we hit our category resolver, we hit a provider which grabs us some information. The scalar leaf nodes of ID and name just get returned using the default resolver I just described, and our attributes field has its own custom resolver which also hits another attribute service and returns us back its scalar nodes. Top level resolvers and root set. So as I mentioned, all GraphQL schemas start with the top level root type or query type. At the top level of every GraphQL, yeah, you have to start with your query, and you also have mutation. I won't be getting into mutation, but you can think of query as your reads and mutations as your writes. But you can see here, we have the top level query, and we have our category resolver being one of the main things we can hit. What's a nested resolver? So nested resolver is essentially a resolver inside a top level. So each field can optionally take additional arguments when defined by the schema. So you can see on this screenshot on the right, for name, we actually can pass in an argument on its own locale because we want to differentiate what's between the English and French. At least in Canada, we have to provide both English and French to our users. So a name is a nested resolver here, a custom nested resolver that takes locale and spits it out. So you can see in the bottom screenshot, in our first argument, this is the root argument coming from the parent resolver. So this is the raw data being returned for the category. We have the name in English and name in French. And then the second parameter is the arguments passed into that resolver on its own. So this is our locale. And here we resolve the name accordingly. So yeah, one of the bad practices that we learned a bit of the hard way over the past couple of years is don't resolve subfields in a parent resolver. So you can see from this first screenshot at our category resolver, we have we're basically taking out we're grabbing the raw category, and then we're also grabbing the attributes. So here we're making a call for a category because this is initially what we wanted. We're grabbing the raw category data, and then immediately after, we're calling an attribute service to grab the attributes for that category, and then returning it all as one lump chunk. So behind the scenes, this will work, but there is one problem, and that is if your user in their GraphQL query doesn't actually request attributes, if that's not something they care about, we're actually still making the call to the attribute service provider and kind of wasting an extra fetch for no reason. So in the bottom screenshot, you can see when we've split it out, we have our our category type resolver here, where the attributes field is actually defined as a custom resolver. So this function will only be called if attributes is requested, and it's doing the exact same thing. It's just doing it more with the GraphQL magic. And the second thing is make your schema consistent. So imagine this is the listing service provider. It's returning us, this dummy object of a listing on your classified site. So we get back a category ID for this listing. If you need the category name in your result to your client, there's been times where we've tended to just kind of do it on its own. We take category ID, we call the category service for listing, and we bring back the category name and make it part of this listing type on its own. Now, this does work again, but now we have this problem where there's a missing consistency within our schema. And what you really want to do is just return the category object. And then you can, in your query request, you can ask for just the name if that's all you needed. But at least then you're still returning the category type. If your next product question or your next Jira ticket comes through and you need to grab something else on the category, everything is available for you there. You just add it to your query. It's good to go. All right, so I decided I'm going to try and do some live code demoing here. Wish me luck. All right, switch. I don't know if that was a bad idea. Just give me 1 second.
Yeah, you'll have to reshare your screen.
Yeah, I'm going for it here. Can you see my screen now?
Yep, you're golden.
Awesome. Okay, so hopefully this is big enough. So I have 4 tasks I want to go through quickly here. One being go through one more time how the category schema and resolvers work. I want to live demo the initial first bad practice of resolving subfields in the parent resolver. And then I want to add a listing resolver and tap into the category type and show you how a consistent schema can really be beneficial. And then lastly, once our schema is in place, I want to briefly explain and demo CodeGen. So by following the Apollo GraphQL, get started documentation, I was able to create an Apollo server fairly quickly. So you can see here, I have this shrunk providers thing. So this is basically just mock data being returned for categories and for listings and for attributes. Nothing too fancy here. But yeah, where the GraphQL magic starts is our type def. So type def is your schema. So we've defined a type category. These are all the things we want to have accessible to the client. And you can see here, we do allow them to access attributes for this category, and it's returning an array of the attributes type, which you see here. Down here, we have our resolvers. So our top level query resolver, which comes with the category resolver, which we'll be testing in a second. And inside here, like I mentioned before, starting with your root arguments. So you'll never really have any arguments on the root of query, as this is the top level. And then arguments that we pass in. So that will be right into the top category. And then inside here is our context. So I've added into the Apollo server context all the mock data providers that I showed you at the top, just so we can get some mock data to play with. Yeah, so once you've kind of defined all this stuff, it's as simple as starting up an Apollo server, type defs, resolvers, context, spin up the server, you're good to go. All right, so what I'm going to do here is demo what I kind of showed in the screenshots. So I have some console logs to show you that if we query category here with overfetching the attribute subfield inside the top level, I'm going to show you why this is not such a good idea. So if I start up the server, awesome, should be ready to go. This is a Apollo Explorer Studio. It's quite a cool tool. So now that status is green, I can add in our category field here. I'm going to look for ID, name, and let's get some attributes. ID, name, value. You're able to pass in your variables down at the bottom. Oh, I'll have to add locale in for name. There we go. So if I run this query, you can see I have grabbed category 2 of bikes, and I've grabbed the attributes value for itself. So everything worked as expected, even with the bad practice resolver. Now the issue is, you can see here we queried the category resolver and we fetched some attributes. If I clear this, I go back in here, and if I don't request attributes, let's say I don't care about grabbing attributes for this query, and I rerun this, we're going to get our data. If you notice here, we did make a call still to the attributes service for no reason. So this is where it's not ideal. This isn't really efficient. You're losing your GraphQL magic. So if I come here and I get rid of this resolver, bring back this guy, where we're simply just returning the raw category object for category, and then inside our category schema, which relates to this type, gets pointed to this type, we're just going to have a sub resolver or a nested resolver for attributes. So only when we ask for attributes is this going to fire, and then we're actually going to make a network call. So if I save this and restart my server. Go back to here, query this again. So we got our data. I suppose I can do a new category so you can see the difference. But you can see here, we're only querying for category and we're not making a call for attributes at all. So we're saving that network request because the user didn't want it. Now, if we do add in attributes, you see we still get our attributes, yay. And we can see here that the attributes nested resolver was executed. So this is something to definitely keep in mind. Make sure you're using your nested resolvers properly. It'll keep things running smoothly, and it'll really give you the magic that is GraphQL. All right, so that's gone through how this works. We demoed that. Let's add a listing resolver. So we're working on a view item page, right? And we want to add the ability to grab some listings. We already have an API set up to grab some listings data. We can see here that the listings object returns an ID, it returns a title, it returns a category ID, and it returns a user ID. Cool. So first we're going to type what this listing is. So listing, we want to return to our client the ID. We want to return the title string, and we want to return a category name, right? So we can tell the user what category this is in. And this, technically, we need to also pass the locale for this. Oh, so we gotta pass the locale in as well. So this is where I mentioned in the initial slides, like this is one way we would go about doing it. We would kind of redefine listing and grabbing its category all on its own. So if I come down to here and I add a listing resolver here, so we're going to grab the ID. We want to grab it from listing service resolver. This would be the listings. Listings. Listing ID. I think I've done everything I need here. Let's see. Restart the server. Oh, wait, no, I forgot to. So I added my listing type, but I didn't add my listing into the main query resolver, so it's not actually going to be accessible. So we need to pass int or ID here, and it's going to return the type listing. So now we know that this returns type listing, which will allow us to create a sub resolver after. Okay, so save this. Start this up again. Yay, we're working. All righty. So I'm going to go back to the start here. So now you can see we have a listing capability here. Nice. ID, title, category name. Oh, not sure if this is going to work. Listing ID. Oh, need to have a listing ID here. Okay, so category ID. So we're getting our listing back, but we're not getting category name. And that is because we actually need to grab the category name directly because we're not properly using a subresolver. So what you could do is add your listing. Add your category name. And actually, I'm not sure if I added this here. Hold on. All right, I'm just getting category ID. Hold on a second. So here we would do, we try to grab the category because we get the category ID from the parent. Category service provider needs to be extracted from the context. ID, category ID. Oh God, what did I get myself into here? And then we want to return the category dot, oh yeah, based on locale. So if locale is equal to English, we want to return these guys, right? Oops. I got a touch bar. Okay. Can you still hear me? I accidentally just hit my touch bar. Yeah, I think we're good. Okay. So now this should work. If I clear, restart my server. So now I should be able to grab category name. Yay, I got velos. I can switch the locale to English. Yeah, I get bikes. So I know I did that kind of quickly, so I'll just explain. So basically, we know we wanted to get category name underneath the listing. So inside here, we just did a call right to category service provider to grab the category, and using that locale, we figured out if we wanted name in English or French, right? And this category ID, again, comes from the top level. And here, listing service provider gives us the category ID. So that's the root argument. So why is this bad? So the problem with this is, what happens if something changes about category names in terms of how it gets passed down from the category service provider? We've sort of redefined this category type into its own on listing. What happens if our product team now wants us to add some other entities from category onto your listings page? You're going to have to come in and add all these fields manually every time, right? Whereas if we just switch this up so that listing just returns the category, and it returns a category type. Yay. So we already have this type defined. It already has its own sub-resolvers already built, right? It's already ready to go. So we pass category as a type to listing. And if we come down to here, now instead of doing category name, we'll just do category. And now we can basically just return the entire category type. So when we ask for category, it's going to grab the whole category object. It's going to pass it down, and then it's going to tap into its own sub-resolver fields that are already created. And we're going to be able to access name from the sub-resolver fields that have already been created. And if anything else is needed in the future, they're going to be ready to go. If someone comes in and adds anything else to this category resolver, it's going to be ready to go for listing as well. So let me just demo this. If I close this down, start it up, this should work. So now you can see category name is no longer part of the schema, but we do have category. And inside here, I want name, locale. This doesn't have to be that, it could just be locale. We don't need this. So now if I run this query, yay, we got our name for bikes, velos. And then if we need anything else in the future, attributes, ID, name, values, we're ready to get them. We didn't have to do any extra work. We're tapping into the work that's already been done. So those are the two things I've I found with resolvers is once you really get a good understanding of how they work, you're able to use GraphQL the way it's supposed to be used. So I hope that made sense. It was a little bit nerve-wracking demoing that live, but you can see here it's working pretty nicely. So now that we have a schema that seems to work, I want to just show you one more thing, which is CodeGen. So this is our React TypeScript client app. I've simply just done a React Create app. I spun up an Apollo client. I'm talking to my host here. And what I want to do is I want to be able to query this API that I've created, query this GraphQL schema. And what we've done at Kijiji in the past is we've had to rewrite all the types. We've had to basically, whatever types we've written in the API, we've had to kind of duplicate down manually in our front-end code base. And this, I only realized just recently, there's this beautiful thing called CodeGen, which does all the work for you. So if I go into here, and now that I've installed CodeGen, it was pretty simple. It took like 5 minutes. I can run CodeGen. So it basically uses an introspection query to ask the API, like, hey, return me everything about what your schema is, and it returns the entire schema in one flat file, and all the types that are defined in the GraphQL schema, and it lets the TypeScript, the code generator translate to TypeScript types, and then it generates some outputs. So if we go into this generated folder, which I in my CodeGen YAML, I believe, yeah, I indicated here, this is where I want my output. It's scanning throughout my whole document for any GraphQL files. I'll explain that in 1 second. So if I go into here, you'll notice that, ooh, I have all these types auto-generated. Here's my attribute, here's my category, here's the arguments for category name, which is the locale. So everything is here, listing, awesome. I just added that a second ago, and it was just auto-generated. And then where the real beauty comes in is React hooks. So it even auto-generates you React hooks to query your queries on the API server. So you can just import this now, use get category query, and it's all fully typed and ready to go, ready to be used. So this is like super handy. You even get the lazy queries out of the box. So you notice here we don't have the listing query that we just added. So that is because in the CodeGen YAML, what it does is, for the hooks at least, it scans for any GraphQL files to grab the data it needs. So right now I only have a query for get category query. So if I add a new file here, new file, get listing .graphql. And if I go back to here and paste this in from our thing, do that. Now if I regenerate, it should have found this listing file as well, and also generated now the hooks for use listing. So if I come down here, use query, did it work? Didn't work. What did I do wrong? Oh, it's probably because I named it incorrectly. Get listing. Let's try that again. Cool. If I go into this file, do we have a get listing? There it is. So you can see all the query variables already. We need the listing ID, of course, and then the locale if we want the name. And then we have our get listing query stuff ready to go here. Do we have a use get listing? Use get listing. Yay, there's our hooks ready to go. How beautiful is that? So that is basically the end of my demo. I hope I didn't go too fast. I think I used all my time. Wow, I thought it was gonna be way short. Yeah, I guess
Right
I
on
don't know if we have
time.
time for questions, but I'm all done.
Right on time. Very brave doing live demo. Well done. Well done. Let's see. I don't see any questions in the chat. I see lots of people applauding your live demoing though, so well done.
Thank you.
There you go. All right. Well, if there are any questions for Matthew, we'll have a few more comments coming from the audience. Awesome demo. Thanks so much. Very cool stuff. Great. So let's move on to the next one, which is actually, I think, one of your colleagues also from KGG. So thank you so much.
Thank you.
See you later.
Have a good day.